There are a couple of ways that you can find a trigonometric function if you already know another trigonometric function. Now, the method that we're going to use to do it today uses Pythagoras' theorem so that you can find exact values. If your question doesn't have a triangle drawn, always draw one and place your angle that you're interested in on that triangle so that you can think it through clearly. And you'll need to work out which quadrant theta is in, because as we know now, there are multiple answers for a question like cos theta equals 1/3. There's lots of things that theta could be. Okay, now there's two main methods to do this. You can draw a triangle, just make one generic triangle and think about the quadrants, or you can actually draw up the quadrants and place your triangle in the quadrants where it could fit. I'm going to show you both methods and the advantages and disadvantages of each. In this example question, it says cos theta equals 1/3, find sine theta. Now, you might be thinking, all right, if cos theta equals 1/3, can't I just put into my calculator inverse cos of 1/3, and that gives me 70.528 degrees. So if I know what theta is, 70 and a bit degrees, can't I then just put in sine of the answer and find it that way? Well, yeah, you can. And the answer comes out as 0.942, but what we want is an exact value. We also want to be able to consider that there might be more than one value. So the quadrant method says, all right, if cos of theta is 1/3 and it's positive 1/3, which quadrants are cos positive in? Well, sine, cos and theta are all positive in the first quadrant. And cos is also positive down here in the fourth quadrant. All stations to central reminds you how to find that. So it must be up here or here. So as we're going to draw our triangle, we can place theta there, or we can place theta down here, knowing that 360 minus theta is going to be the same as theta. Sorry, that's a little bit messy. Okay, so now we've got it drawn in two quadrants, we can think, okay, if cos theta is 1/3, cos is adjacent over hypotenuse. Obviously my picture's not to scale, and that doesn't really matter. So we've got 1/3, 1/3. Now if I go to find sine of theta, and this is a right angle here and here, all I've really got to do is find this side, and that's where the Pythag comes in. So we say 1 squared plus something squared. Let's just call this x for now. This one can also be x. And let's say 1 squared plus x squared equals 3 squared. So 1 plus x squared must be 9. X squared is 8, and taking the square root of both sides, x is the square root of 8. Now at that point you'll probably note that you can change that into the square root of 4 times the square root of 2, and you get 2 root 2. So we can now place that on our picture, 2 root 2, and down here this length is also 2 root 2. Now here's where, for me, the tricky part comes in with using the quadrant method. Obviously there's two possible answers, or two possible quadrants that theta could be in. And this length is definitely 2 root 2 in both these cases. The difference is, if you are looking at this as being on the coordinate plane, then this point over here would be 2 root 2. But this point down here would be minus 2 root 2. And often in textbooks, they'll list this part over here with a negative, which sort of doesn't sit quite right with me because a length should be positive. They often acknowledge that in textbooks and say, we know it's a length and we know it's positive, but we're just labelling it minus 2 root 2 because we know that it's lining up with that point. So you can see that method is sort of handy because you're straight away thinking about quadrants, you're drawing it on quadrants. It's just got that little bit of an awkwardness with lengths possibly being negative. The other way that you could do it would be just to draw one triangle and say, all right, if I've got theta sitting in a right angle triangle and I need to make the cos of theta 1/3, cos is adjacent over hypotenuse, you go through the same process here, just doing it on one triangle. Then you say, all right, I'm going to think about which quadrant it's in. So it could either be in the first or fourth quadrant. Okay, now why do we need to think about quadrant? Well, we need to answer the second part of the question, find sine theta. All right, over here looking at this triangle where it's nice and straightforward, sine theta is just going to be opposite over hypotenuse. So we'd write sine theta equals 2 root 2 over 3. But at that point we need to think about the sign of this answer. Because if it's here in the first quadrant, sign's positive there, but down here in the fourth quadrant, it's actually negative. So the answer could be, sign of theta could be positive or it could be negative, so you'll need to put a plus or minus in there like that. And there's two answers to this question. You could also say 2 root 2 over 3 or negative 2 root 2 over 3, but it's quicker and easier to put that plus or minus in there. Now some answers will have a plus and a minus like that. Some actually will be positive or negative because they'll have given you another clue, something else about quadrant. For example, they might say, if tan theta is positive, find sine theta. At which point you'd say, well, if tan theta is positive, it can't be this one down here. We must be only talking about this one where sine's positive, and that would give you that little bit of a clue about what sine theta is.